Welcome to part 4 of chapter 8, where we talk about the so called Six Sigma movement. Our discussion on quality and project quality management would not be complete without the discussion on the Six Sigma movement. It's something that has been around, I would say, since 1990s. I think it's fading out of fashion a little bit, but it's still quite well known in the field of management and quality management. So, what is Six Sigma? It's a comprehensive and flexible system for achieving, sustaining, and maximizing business success. So, Six Sigma movement means, assumes that quality is not the end result. It's really a pathway to broader business success. Six Sigma is different from other movements because it's uniquely driven by close understanding of customer needs. So quality is largely defined in terms of customer requirements, customer needs, customer expectations, and if you meet those expectations, it means you have ensured quality. Also, disciplined use of facts, data, and statistical analysis. This aspect of Six Sigma is coming back into fashion. Nowadays, everybody is talking about data driven decision making and data driven organizations. So it's all about data, not about subjective opinion. It's all about objective data and analysis. And also diligent attention to managing, improving, and reinventing business processes, or BPR. So quality means you need to revise your processes first. Again, BPR is something that's fading out of fashion. It's been around since 1990s, but it's still quite important, and it's not going anywhere because indeed, if you have inefficient processes that breed mistakes, breed errors, then you're not going to ensure quality. Some basic information on Six Sigma. Now, the goal of Six Sigma is almost perfection, where there are no more than 3.4 defects per million opportunities. If you took statistics, you'll probably understand that sigma refers to standard deviation. Statistics tells us that if a particular variable is normally distributed where most of the values are clustered around mu or the central value, then 99% of values will be within 3 standard deviations, right? So here we have 3 sigma plus 3 sigma. Here we have minus 3 sigma, right? So 99% is something like 99.74%, I believe, will be within 3 standard deviations. Now, Six Sigma means even further, right? So it's like really 1 in a million, right? So the probability associated with this extreme value that is 6 sigmas away is very small. So Six Sigma means only, the percentage of those deviations is just very small. The principles that are applied in Six Sigma, they can be applied to a variety of processes and situations, not just to quality issues. Something that seems to be at the heart of the Six Sigma movement is the so-called 5-phase improvement process called DMAIC. I think that's how it's pronounced. DMAIC is a systematic closed-loop process for continuous improvement that is scientific and fact-based. So DMAIC stands for define, measure, analyze, improve, and control. If you feel you have a problem, be it a problem related to quality or customer satisfaction or something else, the first thing you need to do, you need to define the problem, opportunity, process, and customer requirements. In other words, you need to define your problem area, right? Because scientists, they don't deal with things that cannot be measured, right? Like faith, personal beliefs, convictions. Scientists, they deal with something that can be measured, right, in objective fashion, like using a device or using some kind of survey tool. So let's say, if you feel you have a problem with customers or students, let's say we're talking about a university or a college, you need to clearly define that problem. So you can define, the problem with student satisfaction in terms of student satisfaction ranking that you obtain as a result of administering some kind of exit survey where graduated students fill in a survey telling the university how satisfied they are with their studies. Okay, so once you define it in terms of satisfaction score, you can measure it, right? You can measure it using a survey. Once you obtain survey data, you analyze it. You scrutinize the student satisfaction using a formal statistical tests to see whether there's any kind of pattern. Once you understand what seems to be the main reason, let's say you find like a big correlation between student satisfaction and faculty availability, then you can improve student satisfaction by making faculty more available to students. Let's say you ask faculty to hold additional office hours. But once you issue that decree, that new policy that office hours have to be increased, you need to control it, because some faculty, they may still skip those additional office hours. So although you have a solution, the solution is not working because you're not controlling for it. So maybe you will ask department chairs to control, faculty adhering to their office hours, right? So that's the whole cycle of addressing a problem. I applied it to a situation involving students, but it didn't be applied to any kind of other quality situation, including problems related to software or IT in general. For example, let's say you're running a software company, or you're running a software project, and you feel that customers, meaning people for whom you're developing your software solutions, are complaining about poor quality of your solution, right? First thing you need to do to address this problem is to define what do you mean by poor quality. Let's say you define poor quality in terms of the system downtime, right? Percentage of downtime. So that's clear definition. Once you define it like that, then you can measure it, right? So if we're talking about a network and we define the quality of that network in terms of downtime, the less the downtime, the higher the quality, then you can measure it, right? You can see how much downtime you have. Once you measure it, you can analyze it. What is this downtime related to? So let's say based on your analysis, you discover that downtime seems to be correlated to the time of the day. At a particular time of the day, you have a lot of users using the network, and that creates lag, and that brings the entire system down, right? Or the entire network down. So once you analyze it, you can improve it. Let's say you will allocate additional capacity, additional bandwidth during those critical times of the day or of the week. And then you need to control it, right? You need to control that this capacity is consistently allocated, not just once in a while. So that's an example of applying DMake to a quality issue in relation to a network or software application, or just an information system that includes both hardware and software. Now, some people get certifications in Six Sigma movement. The training for Six Sigma involves a lot of project management concept, tools, and techniques. So Six Sigma movement has a lot of overlap with project management, at least as defined and as taught in this class. The idea here is that if you're consistent and disciplined and you adopt all the best practices in project management, then you will ensure the quality of the final deliverable. For example, Six Sigma projects often use business cases, project charters, schedules, budgets, and so forth, just like normal projects. Also, Six Sigma projects are done in teams, and the project manager is often called the team leader under the Six Sigma movement perspective, and the sponsor of the project is called the champion. So there's a lot of overlap between Six Sigma and project management. So that completes part 4 of chapter 8. Thank you for watching.